Good morning, everyone. In the last session, we discussed about the one of the important example called interfaces here, and we identify the how we can come up with the custom example, like we come up with a int stack, and we define the two methods inside this particular int stack, and finally we implemented those interfaces section like whatever the method we define inside this particular interfaces, all the method we implemented here. Okay, so finally, what we did in the last session, this is the dynamic array creation here. Okay, so this is the one of the important example we discussed in the last session, dynamic array creations here. Now, what I will do, so today we are going to discuss about the another important concept to call how we can extend the interfaces here. Can you imagine how we can extend this particular interfaces? So this is important example we are discussing here. Now what I will do, here I'm going to create a one interface here, and this particular interface I'm trying to extend with another interface here. Okay, observe carefully how I'm going to write this particular interfaces here. Getting the point. So this is one of the important example we are going to discuss here. Something like interface A, and this particular interface A, now what I will do, I'm going to finish this, and here I'm trying to write the another interface. Like first I will define the sum of the method which I'm going to use inside this particular interface here. Okay, let me write the methods here, whatever the method I'm using. So this is nothing but the meth1 and another one meth2. Okay, so these are all the two methods. So this is the first interface I'm defining, and I'm going to define the one more interface, interface B. So this particular interface B, now what I will do, I'm going to extend from the interface here. Okay, I'm trying to extend from the this particular interface here. So anything I'm missing? Sorry, this is the class I created. Okay, now you can see, so interface A is the one interface I've created, and the second interface I'm trying to create as a interface B. Now what we are doing here, I'm trying to extending from the this particular interface called interface A, and inside this particular interface B, I'm going to write one of the method called meth3. Okay, so this is another important example we are discussing here. So right now, how this particular hierarchy it is going to look like here. If I'm going to write interface A, and it is trying to extending with this particular interface B. Okay, here what is the keyword I'm using? Extends keyword I'm using, and this is the super interface, and this is the sub interface. Okay, so now what we need to understand here, if here we are having two methods. What are the two methods we are having? Something like m1 and m2. Getting the point? So m1 and m2, and interface B we are having m3. So these are all the three methods we are having. So these three methods, basically what we will do, we'll try to override inside this particular class. Whenever we are trying to implement the particular class, we'll override the all the methods here. Whatever the methods we are having right now, all the methods we are going to override here. Okay, so this is the one of the important example we are going to discuss here. Getting the point? So we'll see how we can write these particular examples here. Getting the point? But we need to understand the hierarchy first. It is important here. What is the hierarchy I'm using? Interface A and interface B. I'm using the keyword called extend here. Whenever we are trying to make the relation between the two interfaces, so we are going to use the keyword called extends here. And what happens here, whenever we are extending, all the superclass functionality is available into this particular sub information here. Like basically, this is the sub interface here. All the super interface functionality is now available inside into this particular sub interface called interface B, something like M2, sorry, M3. This is the physical method is available M3, and these two logical methods are going to available inside this particular interface called interface B. Okay. Now, what I will do, this particular interface B, we are going to implement here. We are going to use the implements with the help of this particular subclass here. So carefully observe this particular hierarchy. Interface to interface, I'm using the extends keyword, but whenever interface to class I'm using, here I'm defining the implements keyword. Getting the point. This is important information we need to understand here. Right. Whenever we are using the class to class, we are going to use the extends keyword. Interface to interface also we are going to use the extends keyword. But the problem, whenever we are trying to use the interface to a class, getting the point, interface to class, we'll use the implements keyword here. Okay, we'll use the implements keyword here. Okay, this is the basic hierarchy. Now what we are going to implement this. Okay, we'll go to this particular example. Now I define the method called M3. Now I'm going to write the implementation class. So here I'm going to write the one class here, something like interface ABIMPL. Okay, ABIMPL basic is nothing but interface A and interface B. I define the two interfaces here. I'm going to write the implementation class here. Okay, let me write this, and here I'm going to use the keyword called implements, and I'm trying to write the sub interface here. I'm going to implement the sub interface. Why I'm going to implement the sub interface? Because the sub interface can contain the two logical method, one physical method. Okay, interface B. This is important, we need to understand. Now what I'm doing is I'm trying to write all the unimplement method. So how many unimplemented method we are going to write here? 3 unimplemented method we are going to write. Okay, this is important information we need to understand here. This is the one of the important information we need to understand here. Let's see method 1, method 2, and method 3. These are all the three methods we are discussing here. These are all the three methods we are discussing here. Now I'm going to override all the three methods. So simple implementation I'm going to write here, because the core Java basically will try to focus more on the functionality, how it is going to work. So using this particular functionality, we'll try to write the implementation in our upcoming frameworks here. Like we'll try to implement all the concepts in our Spring related technologies. Okay, so but inside the core Java, we'll try to focus more on the how this particular functionality it is going to work. For that, I'm not writing much code here. Simply we'll write the print statement. This print statement will give you the more information how this particular example is going to work. Okay, so observe carefully. Implemented method 1 method. Okay, same way. Now what I will do, I will copy this print statement here. So and finally method 1, method 2, and method 3. Method 1, method 2, and method 3. Getting the point. So whenever I'm trying to create an object of this particular interface IMPL, now what I will do, we can access all three example here. But what we need to understand here, what we need to understand basically here, how this particular interfaces and classes we are going to make the relations here. Now interface AB demo. Okay, so this is important, we need to understand here. Now once I created this particular main class, I'm going to create an object. So how I'm going to create an object here? Now you can create the child class, or you can create the subclass, the sub interface references here. Okay, so this is very important information we need to understand here. So something like interface B, I'm providing here something like IB, and new, what I'm doing here, I'm trying to create the child class object. So what is the child class object I'm having here? Something like interface AB IMPL. Okay, so this is okay. N also small. Now you can see what I'm doing is interface I'm creating. Interface B, it is a sub interface, and this is the implementation class object. So this is we'll discuss here. This is basically we are trying to create the super class reference with the subclass object. Same way super interface with the subclass object here. So how we are calling the super interface? Because here INA is nothing but interface A. Now internally we are trying to work on the INB interface B, and internally we are trying to write the AB IMPL. Okay, AB IMPL is our subclass. Okay, this is the object we created. This is pointing as an intermediate, and this is the super interface here. Okay, this is the super interface. This is basically super interface. Okay, and this is basically it is working as a intermediate behavior, because for this particular class it is a super interface, and for this particular interface it is a sub. So I'm going to write here intermediate here. So this hierarchy we already discussed in a previous example here, but only the difference is here, but we are making interface to interface as a extends keyword. Getting the point? Here I'm using extends keyword, and here I'm using implements keyword. Here I'm using implements keyword. Okay, this is very important example we need to understand here. Getting the point? This is the one of the important example we need to understand how this particular objects are creating internally. So finally, what I will do, I'm going to create object. So object is created. I'm going to access the IB dot whatever the three methods we are having. I'm trying to access this particular three methods. So right now I'm accessing only one method. I'm accessing one method. Now the first method is called here. Same way, IB dot method2 and IB dot so method 3. Now if I'm trying to call, the three methods are going to execute here. Now you can see method 1, method 2, and method 3. So this is the important information we need to understand whenever we are making the interface and class section. Okay. So any questions here? Okay, so if we don't have anything here, now what I will do, so I will try to explain the default methods here, how this particular default methods are having inside this particular interfaces here. Because I explained this particular default interface, like default method is introduced from the 1.8 onwards here. Okay, now we'll see how we can write this particular default method. So how I'm trying to write this particular default method, and here only I'm going to write the default method logic. I'm going to expand inside this particular interface B. Here I'm going to write the default method. So something like default string here. Default string get string method I'm writing here, and return. Now what I will do here, I'm going to write the message called default string. Okay, so I'm not writing much code here. So simple method I'm defining it. So this is, we'll call it as a default method. If I'm removing this, it is getting an error, because so either we need to provide the default or static. Otherwise, we can make the method as abstract. only the three applications, like the three information we can add inside this particular interface. The first one, we can write a default method, or if you are not interested, we can write the static method. And if you are not interested, what we can do, we can go for the abstract method here. We can go for the abstract method. Okay, so these are all the three important information we need to understand here. So now what I will do here, now what I will do, so I am going to write the default right now. Later we'll discuss about the another important concept here. So let me make default as it is here. Whenever I'm making this particular default as it is here, so here what I will do, I'm going to print this particular sysout ib dot get string method, ib dot get string method, and here whenever I'm trying to run the default string, but where I define this particular default string, I define inside this particular interface here. I define this particular inside this particular interface. Now what I will do, the same method I'm going to override into this particular class here. So here I'm going to override here. I'm going to override here. Now you can see this is the get string method. Now what I am doing is, so this is very important, we need to understand how it is calling internally interface b dot super dot get to string. Okay, get to, sorry, not to string, get to string here. Now what we need to understand here, how we are calling interface b dot super dot get to string. What happens here if I'm trying to remove this? If I'm trying to remove, what happens right now? It is getting an error here. Why it is getting an error? Because what we need to understand here, what we need to understand this, the method getString is undefined in the type of object. This is very important, we need to understand. So this section we discussed in the earlier class also. So super keyword basically, it will work on the object classes information. Now you can see this is the interface ABIMPL, this is the class. Now this is implemented here, but if this particular class is extended with any other class, it will try to look up this method, the getString method. It will try to look up in the super class, but right now we don't have any super class. The default super class is basically object class. So inside the object class right now we don't have a get to string method. For example, instead of this particular get to string, if I'm going to call to string, okay, if I'm going to call this particular to string, now observe carefully, I'm not getting any error. Why? Why I'm not getting any error? Basically, what we need to understand here, this toString method which is coming from the object class. Right now, I'm not defining any the toString method inside this particular class. So the default to toString method which is going to call from the object class. But here, whatever the earlier method we called here, whatever the earlier method we call here, the getString method, this is not available inside the object class. So this is available inside the interface here. And here, what is the name of the interface we are having? Something like interface b dot super dot get string. Anything I'm missing here? So here I'm missing R. Okay, interface b dot super dot get string. Now compiler understanding. So inside this particular interface b, so there is a method called get string. Now what happens here if I'm not adding this? If I'm not adding this, okay, basically this kind of method will work on the only static related behavior, not for this particular default method. Now you can see cannot make a static reference to non-static method. Okay, so this is I already identified this information, cannot make a static reference to the non-static method. What is the non-static method here? Get string method. And what we are doing here, with help of this particular interface b dot get string we are calling. This is basically when we are going to call whenever the static related information, we'll call this information. Like we are going to call like this. When we are having the static method, we'll try to call like this, because interface name or class name, with help of the class name or interface name, we are going to call the static methods here. Okay, this is we already discussed in the last example here, but now because of this particular non-static method, we need to add this particular super keyword. But right now I'm not calling the super class here. So what I will do, I'm going to write the simple message implemented in subclass. Okay, this is the message I want to add. So just for understanding, I'm writing it. Now I'm going to call. Earlier, now you can see we call the default string. Now I'm trying to call the same example. So whenever we are calling this, now you can see implemented in subclass. Implemented in subclass. So now what happens internally? So you can write the default logic inside this particular interface. You can write the default logic inside this particular interface. Same way, if you are interested to override this particular method for the specific purpose, get it, man. If you are interested to override this particular method for the specific requirement, now what we can do, override the same method in the subclass. Get it, man. Override the same method in the subclass, and now you can define the whatever the logic you are expecting. So basically, this is the specific logic I implemented for this particular class call, whatever the class we define, interface AB IMPL. And if you are not interested, what happens internally? So it will try to look up the default logic. Okay, so it will try to look up the default logic here. Now you can see whenever I'm trying to call this example, now again it will go for the default logic. Okay, so this is the behavior of this particular default method, so which is introduced in the 1.8 onwards here. Okay, so any questions here? Now we'll move on to the another important concept to call. Getting the point? Another important concept to call.
ఐపీ అంటే ఏంటి సార్? ఐపీ నా 8th లైన్ సార్.
ఎయిత్ సి ఐబి అనేది బేసిక్ గా రెఫరెన్స్ ఇక్కడ. నేను ఇక్కడ
డేటా
ఆబ్జెక్ట్ క్రియేట్ చేశాను. చెప్పు.
డేటా టైప్ సార్. డేటా టైప్ సార్ అంటున్నా ఐపీ.
ఈ డేటా టైప్ ఇది ఇంటర్ఫేస్ బి అనే డేటా టైప్ ఇది.
ఓకే. ఓకే.
ఐబి అనేది ఒక వేరియబుల్. ఈ వేరియబుల్ ఏం చేస్తుంది అంటే బేసిక్ గా ఈ ఆబ్జెక్ట్ ని ఏదైతే ఇక్కడ ఆబ్జెక్ట్ క్రియేట్ చేస్తానో ఈ ఆబ్జెక్ట్ ని ఈ వేరియబుల్ లో హోల్డ్ చేస్తుంటాం. సో ఈ వేరియబుల్ బేసిక్ గా హీప్ మెమరీలో ఉన్న ఆబ్జెక్ట్ ని పాయింట్అవుట్ చేస్తుంది. సో ఇప్పుడు ఇది హీప్ మెమరీ అనుకుంటే దీంట్లో మనకు ఈ ఆబ్జెక్ట్ కి ఇంత స్పేస్ అలొకేటెడ్ అవుతుంది. ఏ ఆబ్జెక్ట్ కి? ఇంటర్ఫేస్ ఏబి ఐఎంపిఎల్ అనే ఆబ్జెక్ట్ కి. అండ్ ఈ క్లాస్ కి ఏమేమి ఇన్ఫర్మేషన్స్ ఉన్నాయి? మెథడ్ 1, మెథడ్ 2 అండ్ మెథడ్ 3. ఈ 3 మెథడ్ ని మనం యాక్సెస్ చేయడానికి ట్రై చేస్తున్నాం. ఎలా అంటే ఈ రెఫరెన్స్ వేరియబుల్ ద్వారా. ఐబి అనేది ఇప్పుడు M1, M2, M3 ని పాయింట్అవుట్ చేస్తుంది. ఈ M1, M2, M3 ఎక్కడ ఉన్నాయి? హీప్ మెమరీలో ఉన్నాయి. సో అందుకని ఈ ఐబి అనే వేరియబుల్ ని ఇక్కడ డిక్లేర్ చేసాము. సో ఈ వేరియబుల్ టైప్ ఏంటంటే ఇంటర్ఫేస్ బి. సో ఇక్కడ నేను అదే డిస్కస్ చేస్తాను లాస్ట్ ఎగ్జాంపుల్లో. ఇది బేసిక్ గా సూపర్ ఇంటర్ఫేస్ అండ్ ఇది సబ్ క్లాస్ ఆబ్జెక్ట్. హైరార్కీ ఎలా ఉంది అంటే సూపర్ ఇంటర్ఫేస్ అండ్ ఇంటర్మీడియట్ ఇంటర్ఫేస్ అండ్ ఒక సబ్ క్లాస్. ఓకే, దిస్ ఇస్ ద హైరార్కీ వీఆర్ హ్యావింగ్ రైట్ నౌ. ఇది బట్ ఇక్కడ ఆబ్జెక్ట్ క్రియేట్ చేసింది ఈ క్లాసు, టైప్ ఏమో నేను ఈ క్లాస్ టైప్ పెట్టాను. ఎందుకు పెట్టానంటే ఈ ఇంటర్ఫేస్ లోనే మెథడ్స్ ఉన్నాయి, 3 మెథడ్స్ ఉన్నాయి. ఈ 3 మెథడ్స్ ని ఈ ఆబ్జెక్ట్ ద్వారా యాక్సెస్ చేస్తున్నాను. సో డైరెక్ట్లీ ఈ టైప్ కూడా మనం పెట్టుకోవచ్చు. సో ఆ టైప్ ఎలా పెట్టుకోవచ్చు అంటే, సో ఇది సింపుల్ ఎగ్జాంపుల్. ఇంటర్ఫేస్ ఐఎంపిఎల్. నౌ ఐఎమ్ ట్రైంగ్ టు చేంజ్ విత్ ఇంటర్ఫేస్ ఏబి ఐఎంపిఎల్. ఇక్కడ చూస్తే ఎర్లియర్ ఇంటర్ఫేస్ బి అనే రిఫరెన్స్ వేరియబుల్ టైప్ పెట్టాను. ఇక్కడ ఆబ్జెక్ట్ ఇంటర్ఫేస్ ఏబిఐఎంపీల్ ఆబ్జెక్ట్ ని క్రియేట్ చేశాను. సో ఇంటర్ఫేస్ ఏబిఐఎంపీల్ బేసికలీ ఇది ఒక క్లాస్. ఇక్కడ ఇంటర్ఫేస్ ఐఎంపీఎల్ ఇది ఒక క్లాసు, అండ్ ఇది ఇంటర్ఫేస్ బి అనేది ఇంటర్ఫేస్ ఇయర్. ఎందుకంటే ఇక్కడ చూస్తే ఇంప్లిమెంట్స్ వాడుతున్నాం ఇక్కడ. సో ఇంప్లిమెంట్స్ బేసిక్ గా ఓన్లీ ఇంటర్ఫేస్ కే వాడతాం. ఇక్కడ చూసుకుంటే ఇంటర్ఫేస్ బి, ఓకే, ఇంటర్ఫేస్ బి ఇంటర్నల్లీ ఇంటర్ఫేస్ ఏనే ఎక్స్టెండ్ అవుతుంది ఇక్కడ. ఓకే, ఇదే ఈరోజు టాపిక్. బేసిక్ గా ఇంటర్ఫేస్ బి ఈజ్ ఎక్స్టెండింగ్ టు ఇంటర్ఫేస్ ఇయర్. అంటే ఇంటర్ఫేస్ ఇంకో ఇంటర్ఫేస్. సో ఇంటర్ఫేస్ ఇక్కడ ఏ కీవర్డ్ వాడుతున్నాము? ఎక్స్టెన్స్ కీవర్డ్ వాడుతున్నాం. ఎందుకు ఎక్స్టెన్స్ కీవర్డ్ వాడుతున్నాం అంటే రెండు సేమ్ టైప్ ఉన్నాయి. ఇంటర్ఫేస్ ఏ అండ్ ఇంటర్ఫేస్ బి బోత్ ఆర్ హ్యావింగ్ సేమ్ టైప్. సో ఎర్లియర్ క్లాస్ ఏ అండ్ క్లాస్ బి. ఇక్కడ ఏ కీవర్డ్ వాడాము, ఇక్కడ కూడా ఎక్స్టెన్స్ కీవర్డ్ వాడాము. ఓకే, బట్ ఓన్లీ ఇంప్లిమెంట్స్ కీవర్డ్ ఎప్పుడు వాడతామంటే ఇక్కడ ఇంటర్ఫేస్ ఉంటుంది అండ్ ఇక్కడ క్లాస్ ఉంటుంది. సో ఈ కేసులో మాత్రమే ఇంప్లిమెంట్స్ కీవర్డ్ వాడతాం. సో ఇక్కడ ఇంటర్ఫేస్ డిఫైన్ చేశాను, ఇక్కడ క్లాస్ డిఫైన్ చేశాను. సో ఈ రెండు కేసులో మాత్రమే ఇక్కడ ఇంప్లిమెంట్స్ కీవర్డ్ వాడతాం. క్లాస్ టు క్లాస్ ఎక్స్టెండ్ వాడతాము, ఇంటర్ఫేస్ టు ఇంటర్ఫేస్ కూడా ఎక్స్టెన్స్ కీవర్డే వాడతాము. ఓకే, ఇది ఇంపార్టెంట్ ఎగ్జాంపుల్ ఇక్కడ డిస్కస్ చేసింది. సో దానికోసము నేను ఇక్కడ ఇంటర్ఫేస్ బి ఈజ్ ఎక్స్టెండింగ్ ఫ్రమ్ ద ఇంటర్ఫేస్ ఏ అండ్ ఇక్కడ ఒక మెథడ్ డిఫైన్ చేశాను. అండ్ ఇంటర్ఫేస్ ఏలో రెండు మెథడ్స్ ఉన్నవి, మెథడ్ 1 మెథడ్ 2. అండ్ ఇంటర్ఫేస్ బిలో ఒక మెథడ్ ఉంది అండ్ ఇంటర్ఫేస్ బిలో ఒక డిఫాల్ట్ మెథడ్ రాశాను. ఓకే, అండ్ క్లాస్కి వచ్చేసరికి ఈ మూడు మెథడ్ని డిఫైన్ చేశాను. నీకు ఏమైనా రిక్వైర్మెంట్ ఉంటే ఈ మెథడ్ని ఓవర్ రైట్ చేసుకోవాలి, లేదు అంటే ఇంటర్ఫేస్ బిలో ఉన్న ఆ లాజిక్ ఏదైతే డిఫాల్ట్ లాజిక్ ఉందో ఈ డిఫాల్ట్ లాజికే వర్క్ అవుతుంది. ఓకే, బట్ సింపుల్ ఇక్కడ ఏంటంటే ప్రస్తుతానికి నేను ఇది ఒక చిన్న సింగిల్ స్టేట్మెంట్ రాశాను. బట్ ఫ్యూచర్లో వీఆర్ నాట్ గోయింగ్ టు రైట్ దిస్ సింగిల్ స్టేట్మెంట్, విల్ ట్రై టు రైట్ మోర్ దెన్ 1 line code here. Okay, this is very important here. But for this object, now what I'm doing is I created object for this particular interface AB IMPL. Okay, so is it clear? Okay, so to understand more practical, now what we can do, yesterday we discussed about the stack related example. Here we can write the default method. If you are interested, here also we can write the default method. Now what I'm doing here, so this method basically clear method, it will try to remove all the objects from the array here. Okay, it will try to remove all the objects. So right now what I'm doing here, so just I'm going to write the simple method. Clear method is not implemented. So this is only the message I am trying to print this. Okay, so here whenever I'm trying to call this particular clear method, now I will get this particular message. Clear is not implemented. Now what we can do, basically this is the interface here. This is the interface we defined here. Now what is the implementation class? What is the implementation class we are having? Something like fixed stack. Now inside this particular fixed stack, what we can do, you can override the clear method. You can override this particular clear method and you can write whatever the logic you are interested here. Now what we can do basically, whatever the stack we are trying to create this particular stack here, so we can make as a empty here. How we can make as a empty here? So this is basically we don't have the variables here. stck. Okay, so here what we can do, whatever the length we are going to have, based on this particular length we can make the condition. We can make the condition and we can remove the object from this particular, remove the object is nothing but we are going to make as a zero values. Zero values. So to understand this, int I is equals to 0, okay, and I less than stck dot length I'm making the condition, and I plus plus, and here stck, and inside this particular I location I'm going to make as a all the values are 0. Okay, all the values I'm making as a 0. So this is the clear purpose here. Now after calling this particular clear, if you are trying to print the pop method, we can understand here what are all the values we are going to get. So let me go for this particular example where we defined nested if demo, where I created the main example. Maybe I hope here only nested impl is not negative. This is not demo maybe. This is the current example. Okay, this one we created in the earlier. So fixed stack I'm creating it, and 5000 I provided here, and this is for the same pop method. And finally what I will do, so using this particular stck dot clear method I'm calling. Okay, clear method I'm calling. So after calling this particular clear method, if you print any pop method, stck dot pop method. Okay, now again I'm trying to run the same example. Now you can see 0 we are getting. Now you can see here I'm getting as a 0. Why I'm getting 0? Because what happens internally, all the values I made as a 0 here. So this is the purpose of this particular clear. So original values, basically these are all the original values. Now what I did, so instead of this particular 500, I will make as a 5 only. Something like 25 is fine. Okay, so 25 is fine, and same loop I'm going to use here. After clear, I will print the same loop here. Now observe carefully. So stack is underflow. So 0 we are getting, and stack is underflow. Why I'm getting this particular stack is underflow? Because what we are doing basically, we are trying to let me go to the fixed stack. We define this particular message. Okay, so we define this particular message here. So why this particular 0 and why it is printing like this? Let me go to this. Anything we are writing after calling the clear. Okay, after calling this particular clear, basically the pop every time it is checking this particular condition and it is returning 0. Okay, now you can see here I comment out this. Here I can comment out this, and I will go back to our main class, and I will print like this. Now observe. So pop, why it is not printing? So it should return. Okay, here only it is printing. Okay, here only it is printing. In the same line, it is printing all the zeros here. So this is the 5 to 120. It is the original value, and zeros. These zeros are where after calling this particular clear. After calling this particular clear, now I'm trying to print this particular zeros. So if I want to understand more, what I will do, empty println. So empty println I'm using it so that it will print on the next line. Now you can see. So this is first time we are getting all the values, and the second time after calling this particular clear, I'm trying to repeat this particular pop method. So this is it trying to repeat all the zeros here. Getting the point? So this is the way we can define the default method, and based on our requirement, we can override the clear method. Now what I will do, here I'm going to comment out the clear method. So inside this particular fixed stack, here I'm going to comment out this particular clear method. Whenever I'm trying to comment out this particular clear method, I'm going to run the same example. Now you can see what happening internally. So this is a message we are getting. clear is not implemented. Where we define this particular clear is not implemented, this message we define inside this particular interface here. Okay, this message we define inside this particular interface here. So that interface is returning this particular message here. Okay, so this is the important example we are discussing. Same way in the real time also we are going to write same thing. In interface we'll write some logic. If you are not interested, we can override the specific method inside this particular class, and we can write the whatever we are expecting here. Okay, so this is all about the this is all about the clear method. And now we'll move on to the static method. How this particular static method, it is trying to provide the information. So same thing I'm going to write here along with this particular default. Along with this particular default, I'm going back to the interface B. Here I'm going to write the one static method. So how I'm writing the static method? Something like static int get number. Okay, right now I'm trying to return the default number here, 10 multiply 10. Okay, so this is the static method I'm defining. So where I'm defining inside the interface. Inside this particular interface here, I'm trying to define one method called static, and the number what it will do, the default value it will try to return the 10 multiply 10. How many times you are going to call this particular number method? Every time it will return the same output. Okay, every time it will return the same output. But if you are not interested to get this particular same number, what we can do? We can override the important information inside this particular specific class. What is our specific class basically? What is our specific class here? Now we'll go to this particular specific class, nothing but interface ABIMPL. Now again understand here. This is important here. So now you can see here I'm not getting any the method called get number. Getting the point. So why I'm not getting it? The get number. So here you can see we are getting the get string here. Now you can see here the get string method is getting, but I'm not getting the get number because the get number is a static method. The static method basically we are going to call based on the class name or interface name. For example, if I'm going to write so same static into get a number, here I'm trying to write here. So this particular number will return will will return something like 12 multiply 12. Okay, this particular number it will try to return the 12 multiply 12. Now what I will do, I am going to call this particular get number. From where I'm going to call? From this particular our demo class I'm going to call here. So after observe this particular get string, here I'm trying to call. So ib dot get number. ib dot get number. Okay, so this is important, we need to understand. Now the static method basically how I'm calling it with help of this particular object here. With help of this particular object I'm calling. So observe carefully. Now the get number it is printing. Yes, it will print. But so let me print this is out here. I missed because the number it is trying to return some value here. Now you can see. So this is the whatever the value 12 multiply 12 it is returning 144. Okay, so carefully observe. Now here what I will do here I will remove this. So here I will remove interface B. Now you can see I am getting an error. Why I am getting this error? Because interface B it is having a static number we cannot access with help of this particular object. We cannot access this particular object because the static methods, this is important here. The static method basically with the help of class name or interface name we can call here. Static method basically with help of this particular interface or method like interface or the class name, we are going to call the appropriate method. So I'm not going to use this particular IB here. Okay, directly interface b dot get number. Whenever I'm calling this particular interface b dot get number, so what is the value we are going to get here? Something like a 100. 10 multiply 10, we are getting an 100. And now same example, if I'm going to call with this, if I'm going to call with this particular interface B, interface ABIMPL, so here we are going to get as a 144. So now what you understand here, static method basically it is bounded with interface or class here. This is important here because it is not bounded with object here. It is not bounded with a object here. It is bounded with a class or interface name, because if you can see with help of this particular class name we are calling the static method, and earlier so with help of this particular method name, sorry, interface name, we call the get number. So this is the purpose of this particular class, and this is the interface here. So static method basically it is bounded with a class or interface wherever we are trying to define the method. Now I'm trying to call the two methods because this is the specific method which we are going to write in the specific instance like a class or a interface. Okay, so any questions here regarding this particular static here? Now this is we discuss about the one of the important the interface section. Now we'll move on to the exception handling. So what exactly this particular exception handling is going to provide the information. So basically what I want to provide information, so I implemented some example yesterday we implemented one example. We got an error called heap memory, the Java heap memory related example we identified. So why we got this particular error here? Because the memory, whatever the memory we specified here, the memory is filled here. Okay, so we don't have a space here. Because of that, we got an error. Now, whenever we are getting this particular errors here, how we are going to handle here? Getting the point? How we are going to handle? Basically, so this is one of the important example we are discussing, that is called exception handling here. The exception handling basically when the abnormal condition we are going to identify, then we are going to get an exception. Those exceptions we are going to handle in our Java language using some of the keywords. Like inside this particular Java, we have few keywords here. Using those few keywords, we are going to handle the exceptions here. Okay, this is we need to understand basically. And internally, okay, internally, whenever we got any exception, internally, our compiler will create an object here. Which object is going to create? The exception object is going to provide, and it will try to provide the default message here. Okay, it will try to provide the default message. Okay, now observe carefully. Whenever we got any exception, the by default, compiler will create an object and it will try to provide the default message for the exception, why we are getting an exception and what is the root cause of this particular exceptions here. Okay, but what we need to understand here, so using some of the keywords basically we'll try to handle all the exceptions here. Okay, using this particular some of the keyword will try to handle the exception. Now I will provide the simple example why I'm getting an exceptions here. Later we can discuss about the important example, and here only I'm trying to comment out. Okay, here only I'm trying to comment out this particular example. Now into d is equals to 0, into d is equals to 0, and into a is equals to 42 by d, into a is equals to 42 by d. Getting the point? Now what I'm doing here? Here I'm trying to do the division operation. Whenever I'm trying to do this particular division operations here, now I'm going to get an exceptions here. So now you can observe carefully what is the exception name we are getting? Something like arithmetic exception. Okay, arithmetic exception. And this exception is a predefined exception. Getting me? This is the predefined exception which is coming from the our Java language here. Now, what is the message? Slash by 0. Now, what you understand this by reading this particular message? Because whatever the value we are trying to divide with 0, get in by whatever the value we are having, we are trying to divide with this particular 0. Whenever we are trying to divide with this particular 0, we'll get an exception. Okay, we'll get an exception like this. So this is very important example we need to understand here. Now, how we can handle this? Getting the point? So this particular exception, how we are going to handle? Now to handle this, first what do I need to do? This is we need to understand here. Arithmetic exception is a one class. Okay, arithmetic exception is a one class. So public class, name of the class name we define as arithmetic exception, and now you can see it is extending from the runtime exception. Now what you understand here? Up to the inheritance here, whatever we discuss here. So the basic information here. Getting the point? By using this particular basic information, we are going to understand how the Java language internally it is defined here. How this particular Java language internally it is defined here. Now you can see they define the one constructor. It is a default constructor. Internally they are calling the super keyword. Okay. So this particular super we already discussed in the previous example. Now this is the another constructor. They are providing one parameter, and internally they are calling this particular super. Internally they are calling this particular super, and here now you can see they are providing the one parameter. Okay, the super keyword we discuss here, and the like constructors we discuss here, and extends we discuss here, and this is the runtime exception. Now you can see this particular class also, again this runtime exception is expecting two parameters. They are calling two parameters constructor, and this is the one parameter, but the type of parameter is different. So here we are providing throwable, and here we are providing string, but both are expecting only one parameter. So this is the string parameter we are providing it, and this is the object here. This is the object we are providing. Getting the point? So this is a way we can easily understand how this particular the predefined classes are defined internally. These are the predefined classes are internally it is defined. Now what do you understand here? So if I'm going to come back to here, where is this? Yeah, here now if you observe, whenever I'm trying to run this particular example, I'm getting this particular messages here. Now what you understand here? So this is the object is created, arithmetic exception. Arithmetic exception basically it is a one class here. It is a one class here. Getting the point? So this particular class object is created by whom? Compiler it is created whenever we are getting an exception, and this is the predefined message. This is the predefined message is provided by the compiler. Now how we can handle this exception, and how we can provide the our custom message, and one more important information. For example, if I'm going to write this out here, so this is line number 16. Okay, just for understanding I'm writing here the line number 16. So now this line number 16, whatever we defined here, this particular message is going to print or not, we need to understand here. Now you can see whatever the line number 16 we defined here, the line number 16 it's not printing. Why it is not printing here? Getting the point? Whatever the line number 16 we defined here, it is not printing here, because here the line number 15 only we are getting an exception. Whenever we are getting an exception, it is directly it is going to the exception class, creating an object, and throwing an exception. Okay, and the below lines of code, whatever the below lines of code we are going to define here, so those lines of code is not going to execute here. Getting the point? This is important here. Those lines of code is not going to execute. But what we can do, once we handle this particular exception, we can easily execute the remaining statements as well here. Okay. So we'll discuss about the how we can handle this particular examples here. But what we need to understand here, basically, getting the point. So as I explained here, so it is try to create a Java exception object, and it will try to describe the why we are getting this particular exceptions here, and internally it is going to throw the particular exceptions information. Now we'll try to use some of the keyword. The first keyword we are going to use try, and second keyword we are going to use catch. Okay, and the another keyword we are going to use as a throw. Okay, and another keyword we are going to use as a throws, and the last keyword we are going to use as a finally. So these are all the main keyword we are going to use in our exception handling. So using this particular 5 keyword, we are going to write the much example on this particular our exception handling it. Okay, so this is we'll try to identify it, but how exactly we are going to write this particular keywords here. So to understand this particular syntax, first we need to follow syntax. This is the try block. Inside this particular try block, whatever the code, get in bit, whatever the code, it is going to throw an exception. Okay, whatever the code, it is going to throw an exception. So those exception code we are going to write inside this particular try block. Okay, so whatever the code, it is going to throw an exception. We'll try to define inside this particular try block. Now I'm going to add catch block. This particular catch block will handle the exception. The current example, I'm going to write arithmetic example. Okay, arithmetic ex. So this is the catch block I'm defining, because so here we are going to throw an exception. Like the particular code, whatever we are going to write, the code, it may be throw an exception. So once it is thrown, it is trying to handle this particular catch block. Once it is thrown, it is handle this particular catch block, and so we can write multiple catch blocks here. Okay, so we'll identify the catch block information, and finally we are going to write the important information called finally block. This is the finally block we are going to write here. Okay, this is the basic syntax we need to follow. And now you can see how we are writing try block. We are going to write inside the try block whatever the code, it is going to throw an exception. So those particular code we are going to write here, and once it is throw an exception, this particular catch block will handle. And finally block, basically, even if we get any exception, the finally block will execute here, and if you are not getting any exceptions also, the finally block will execute. And this basically, in any case, this particular finally block is going to execute here. Okay, the simple example I'm going to write here, the same whatever we identified here. Here only I'm going to write the try block here. Okay, so here only I'm trying to define the particular try block, and okay, so here I'm trying to write catch block. So we identified the arithmetic exception we are going to get here, the same exception I'm handling it, and here we can write here. So whatever the exception we can write here, arithmetic exception caught here. So we are handling the arithmetic exception, and so finally this is the finally block, and inside this particular finally block, the line number 16 I'm writing here. Okay, the line number 16 statement I'm trying to write. Now observe carefully. So here also you can write the one more statement here. Line number 23. this particular line number 23. So this is line number 23. So just for understanding, I'm writing whether this particular statements are going to execute or not. Okay, this is very important here because earlier, without using this particular try and catch, the below statement is not executed. That we identified here. Now what I'm doing here, I'm going to run. Now you can see here the line number 16 we are getting an exception. The line number 16 I'm getting an exception. The line number 19, the line number 19. So we are printing an exception called arithmetic exception caught. Okay, the same message it is printing it. The arithmetic exception it is called, and later the finally block is executing. After this particular try and catch, whatever the statement we written, those statements also executing here. Getting the point? Now, if we get any exception, now we are handling the exception. And after handling the exception, the below lines of code, whatever the below lines of code we written, those lines of code also it executing here. For example, if I'm trying to comment at this, what happens internally? Will not going to execute this. So here only I'm going to write this. Okay, here I'm going to write these two statements here, and I'm going to comment out this. Here only this comment, this section I'm trying to comment this. Okay, observe carefully. Here I'm trying to run with help of this particular exception. I'm trying to run with help of this particular exception. Only exception we are getting. Only exception we are getting. This particular code is not executing. For example, what we need to understand again, here I'm trying to comment out this. Okay, here I will enable this. I will enable this. Instead of line number 23, I am printing this. Okay, instead of line number 23, this is the section of code I defined inside the try and catch. Inside the try and catch I define here. Okay, and what I am doing here, the below statements. So line number 25, whatever we defined here, the statements I'm trying to executing here. Now you can see. Now you can see the all the three implemented methods are executing. Default string is providing, and 100 sorry 12 value, it's multiplied with 12. The square of this particular 12 I'm getting 144. The square of this particular 10 I'm getting as a 100. Getting the point? The square of this particular 10 I'm getting as a 100. Even though if we get any exception, even though if we are getting an exception, happily the below statements are executing here. Happily the below statement. If you are not interested to write here, inside the finally block you can write. Inside the finally block you can write. All the code is going to execute here. The finally block, this is the advantage we are going to get. Basically, even this particular section of code is not going to execute. For example, I'm giving as a d value, and finally here I'm going to print as a value. Here I'm going to print as this particular a value. Okay, now what we need to understand basically, if I'm going to run this particular example, now I'm getting a value as a 4. After getting an a value, so this particular statement, the line number 22 statement is not executing. Why? Because we are not getting any exception. If we get any exception, if you are getting any exception, this statement will execute. Okay, but right now I'm not getting the value. I'm getting as a 4, and the same whatever the code we define inside the finally block, it is printing. Okay, now you can see here if I modify to 0, the line number 19 will not, the line number 19 will not execute. The a value, whatever the a value we are printing right now, the a value we are not going to get here. So again I'm trying to provide same example one more time. So now you can see the a value is not printing. See, you can write the try and catch. You can write this particular try and catch block. So there is no problem. But what I am suggesting here, if the code, if you are trying to execute this particular code, even if we get any exception or if you are not getting any exception, getting the point. So that particular code we can write inside this particular finally block. Okay. So basically try is going to expect either catch or finally block. If I'm trying to comment out catch also, now we are now we are getting an error. Getting the point? Because now if you read this error, syntax error, insert finally to complete this particular block statement. Now what you understand here basically? Here the try is expecting catch block or finally block. Okay. Now we'll see first catch block here. Now if I'm trying to add this particular catch block here, so it is handling the exception. Now what I will do here, I'm going to enable this particular finally block, and I'm going to comment out the catch block. Okay, I'm going to comment out the catch block. Now you can see we are not getting any compilation error. We are not getting any compilation error. I'm trying to run the same example. I'm trying to run this particular same example, but observe carefully. Even though if you are getting an exception, the finally block is executing. Okay, the finally block is executing, and finally the default exception handling is handling the exception, because right now we don't have a catch block. So now we understand what is the purpose of this particular catch block. If we get any exception, the catch block will handle. Getting the point? If we get any exception, the catch block will handle this particular exceptions here. Okay, so this is very important example we need to understand here. Okay, any questions here? Anyone having any questions? Okay, so if we don't have anything here, now I'm going to stop the session here. So we'll continue the exception handling in the evening session. Okay, we'll continue the same